Good morning to all. I am Julin Joseph, working in Vedavyasa Institute of Technology as Associate Professor in Physics. Today, the Tech Talk session deals with a bright research topic in material science, that is fluorescent materials and its classification and applications. So we all are familiar with fluorescent materials. We have seen different fluorescent materials in our day-to-day life, such as fluorescent marker pen, road reflectors, etc. So the fluorescence means when we apply energy to a material, the electrons in the ground state get excited to higher energy level, and when we to go to higher energy level, there is a hole remain in the ground state. So after some time, the electrons get de-excited to ground state by recombining with this hole, and the energy is released as light. This is known as fluorescence. So the chemical compounds that exhibit fluorescence are generally called fluorophores. There are different kinds of fluorophores such as organic compound, inorganic compound, organometallic compound, and biological fluorophores. But these fluorophores have some drawbacks such as photo blinking, decomposition, and repeater excitation. In addition to these fluorophores, there are some materials which show size-dependent fluorescence properties known as fluorescent nanoparticles. The main fluorescent nanoparticles are semiconductor quantum dots, metal nanoclusters, silicon quantum dots, nanogels, dendrimers, polymer nanoparticle, and carbon nanoparticle. Even though semiconductor quantum dots are toxic, carbon quantum dots and silicon quantum dots are non-toxic. So semiconductor quantum dots means the combination of group 2 to 4 or 3 to 5 semiconductor are known as semiconductor quantum dots. So semiconductor quantum dots have size approximately Bohr exciton radius. They have discrete energy level. They exhibit size dependent emission such as the blue quantum dot exhibit small size and red emitting quantum dot exhibit bigger size. They are applicable in bioimaging, sensing, light emitting diode and solar cell. But these semiconductor conductors are highly toxic and low chemical stability, and preparations are complex. So next we deal with the energy application of fluorescent nanomaterials. First one is in solar cell. So recently the research is going on by in this area, that is by inserting the fluorescent quantum dots in between the layer of solar cell. So in traditional solar cell, it is difficult to harvest infrared photons. Quantum dots which capable enough to absorb infrared photons increase the efficiency of solar cell. So the intention is to harvest more solar energy or more infrared photons. This is possible by inserting the quantum dots in between the solar cell layers. So the quantum dot based light emitting diodes are also created. It exhibit high color purity and efficiency. So the general structure of quantum dot light emitting diodes are as shown in the figure. It consists of an anode, electron transport layer, quantum dot layers, hole transport layer, and cathode. So when the electron and holes are ejected from the electrodes into charge transport layers, the carriers are injected into quantum dots from carrier transport layer, and the radiative recombination of ejected carriers take place in this quantum dots. It have more efficiency and color purity compared to traditional light emitting diodes. So another application of fluorescent quantum dots is photocatalysis and electrocatalysis. The second figure shows hydrogen production using carbon dot and NIP system. So hydrogen can be used as a fuel. So these quantum dots can be used for the production of hydrogen. So another application is the in supercapacitors. So the quantum dots can increase the efficiency of supercapacitors. Recently the work is going on by combining the carbon quantum dot or graphene quantum dot with carbon nanotube or graphene. Thus the efficiency of supercapacitors can be increased. Another use of quantum dots is lasing action. The fluorescent material which have high quantum yield can be used for lasing action. So the emission is based on the fluorescence emission. So biological application of fluorescent material are bioimaging and drug delivery. Bioimaging means observation of subcellular structures, for example cancer cells, can be directly viewed by using these fluorescent materials. The figure indicates that cancer cell of a mouse. The cancer cells produce some chemical. This fluorescent material get attached to that chemical. Thus, the cancerous cell become fluorescent, and thus the bioimaging can be performed. Another application is drug delivery. Drug delivery is also fluorescent material can be used. Thank you.